Chapter 1, Electrostatic, 2 hours. Subtopic of this topic is 1.1 Coulomb's law, 1.2 electric field, 1.3 electric potential, 1.4 charge in a uniform electric field. Learning outcomes. At the end of this topic, students should be able to 1.1 Coulomb's law. State Coulomb's law. So Coulomb's law is F equal to QQ over 4 pi epsilon naught R square, or KQ Q over R square. B. Sketch the electric force diagram. C. Apply Coulomb's law for a system of point charge. Another learning outcome is 1.2 electric field. Define and use electric field strengths. Use E equal to KQ over R square for point charge. C. Sketch the electric field strength diagram. D. Determine the electric field strength E for a system of charge. Another learning outcomes 1.3 electric potential. A. Define electric potential. B. Define and explain equipotential line and surface of an isolated charge in a uniform electric field. C. Use V equal to KQ over R for a point charge and a system of charge. Maximum for charge in 2D. D. Calculate potential difference between 2 points. Still continue with the learning outcome for 1.3 electric potential. E. Deduce the change in potential energy delta U between 2 points in electric field. Calculate potential energy of a system of point charge up to a maximum 3 charge. Lastly, a learning outcome for 1.4 charge in a uniform electric field. A. Explain qualitatively with the aid of a diagram the motion of a charge in a uniform electric field. B. Use E equal to delta V over D for uniform E in 1. Stationary charge. 2. Charge moving perpendicular to the field. 3. Charge moving parallel to the field. 4. Charge in dynamic equilibrium. 1.1 Coulomb's law. 1.1a State Coulomb's law. So what is a Coulomb's law? Coulomb's law states that the electrostatic force F between two charges separated by a distance r is directly proportional to the product of the magnitude of the charge Q1 and Q2, inversely proportional to the square of the separation distance r between two charges. So in mathematically we can write the Coulomb's law as a F equal to K Q1 Q2 over R square, whereby the Q equal to NE. So N is a number of electrons multiplied with the magnitude of the electrons. So K is a Coulomb constant. The value of K is 9 times 10 of power of 9 Newton meter square per Coulomb square. Q1 is a magnitude of charge Q1, Q2 is a magnitude of charge Q2, are a distance between two charge. So actually K is a 1 over 4 pi epsilon naught. So the value of the K is 9 times 10 of power of 9 Newton meter square per Coulomb square. So figure A and B show the variation of electrostatic force with the distance between two charges. So if you can plot the F against R, so you can get the graph as shown in figure A. So if you plot F over 1 over R square, so you get the figure as shown in figure B. 1.1b Sketch the electric force diagram. The electrostatic force is directed along the line joining the charge. So as you can see in the figure, if the Q1 is a negative, Q2 is a positive, attractive electrostatic force if the two charges have opposite signs. So if the Q1 is a positive, Q2 is positive, then repulsive electrostatic force if two charges have same signs. The notation F12 denote the force exerted on charge 1 by the charge 2, and F21 is the force exerted on charge 2 by charge 1. Since electric force obey Newton's third law, therefore the force F12 is and F21 are equal in magnitude but opposite in direction. They can be written as a F12 is negative F21. 1.2 electric field. 1.2a define and use electric field. So electric field strength E definition: the electric force F acting on test charge that is placed in the electric field region divided by the magnitude charge of the test charge Q naught. So electric field E is F over Q naught. So E is a vector quantity. SI unit for the E is a Newton per coulombs. So physical meaning of an electric field is a region in which an electric force will act on the charge that is placed in the region. So this is a electric field. Properties of electric field lines. So there are six properties of electric field lines. Okay, number one, this electric field line never cross each other, and the number of lines determine the strength of the electric fields. So number two, E is large when the field lines are close together and small when they are far apart. So a positive and negative charge can produce electric fields. So number four, the number of electric field line entering or leaving a charge is proportional to the magnitude of the charge. So we continue with the electric field line properties. Okay, number five, the direction of E for a positive point charge is upward from the charge in all direction. So this is very important. So positive is upwards. So meanwhile the negative is towards. So number six, the direction of E of a negative charge is toward the charge in all direction. So this is very important. Positive is upward from the charge, so negative is toward the charge. Electric field line pattern between two charge. So as you can see in the figure, so electric field line pattern for two equal and opposite point charge. So as you can see in the figure 1, positive is upwards, so negative is inwards. So number 2, electric field line pattern of two equal positive point charge. So this is a positive is outwards, so also positive is outwards, but is repel each other. Okay, number 3, electric field line pattern for a point charge for positive 2q and a second point charge negative q. So as you can see, positive is outward, negative is inwards. Uniform electric field line in parallel plates. So this is a parallel plates. Okay, electric field line pattern for two opposite charge parallel plates. The electric field line are perpendicular to surface of the metal plate. The line go directly from a positive plate to a negative plate. The field lines are parallel and equally spaced in the central region, far from the edge of the fringes, outward near the edge. In the central region, the electric field has the same magnitude at all points. So as you can see in the figure, so electric field is from positive to negative. So this is very important. So when you draw the electric field, you have to minimum 3 line. So this is very important. 1.2b, use E for a point charge, electric field strength for a point charge. Consider a test charge Q naught located at a distance R for a point charge Q. So, according to the Coulomb's law, F equal to K Q naught over R square. From definition, E equal to F over F naught. So you put the equation number 1 to equation number 2, then you get another E. So E is K Q over R square. So whereby the K is a Coulomb's constant, Q is a point charge, R is this distant point from the point charge. So this is another formula for the electric field strength E. So formula for the electric field strength, so we have two formula. One is F over Q naught, another formula is K Q over R square. Notice that E is inversely proportional to the R square. So the relationship between E and R can be shown in figure below. So if you sketch a graph E against R, so you get inversely. The strength of E will decrease when the distance from the point charge increase.